Okay, so sum and difference of tangents formula. So there will be a podcast of this now. Basically, this works out exactly the same as what we did before for sum and difference of sine and cosine, just different formula again. You are going to have these formulas memorized for the quiz. Absolutely, yes. Formulas need to be memorized. So you will not be given them. That's probably going to be the biggest obstacle for a lot of people, is knowing your formulas. Once you know the formulas, the work is pretty repetitious. Nice thing about the tangent formula, it's pretty easy to remember because it involves only tangent. There's no sines and cosines involved, only tangents. So tangent formula. And the numerator looks just like I did a distributive property over what we started with. So the sign is always the same. Tangent of alpha plus beta is tangent alpha plus tangent beta over 1 minus tan alpha times tan beta. So the signs are opposite in numerator denominator. The numerator always matches the original. The denominator is the opposite. The numerator just looks like we did a distributive property. The denominator has the product. So knowing the formulas is key. Once we have them, everything pretty much works the same way we did before. The only thing we have to be careful about with the tangent formula is it is a little bit extra work when we're dealing with identity angles. We have to be careful in certain circumstances. So I'm just going to jump down here real quick. If you're choosing angles for a sum or difference identity, try to choose combinations that don't use fractions for the tangent of alpha or beta. For example, if I'm doing tangent of 165, if that's one of the angles I'm looking for, I could do it as 120 plus 45 or 135 plus 30. Either one gets me there. Both those get me to 165. If I do 120 and 45, I mean the tangent of 120 is negative root 3 and the tangent of 45 is 1. That is good. That's a smiley face. Because I don't have any fractions as part of my values of tangent. If I get fractions for part of my value of tangent, now I'm going to get complex fractions within my formula because I'm going to have fractions within the fraction. That's more difficult. If I chose the 135 and 30, well, tangent of 135 is negative 1. Tangent of 30 is root 3 over 3. That's not so nice. Because now when I plug my numbers in the formula, I'm going to have root 3 over 3, both the numerator and denominator of my fraction. So now I've got fractions within my fraction, much more difficult to work with. So strategy-wise, once I know the formula, next step is always deciding what values am I going to choose to set up whatever I'm looking for, especially if it's an identity situation. If it's a non-identity, it works just like what we did before. You just plug the numbers in the formula and go. Draw your triangles, make sure you're in the right quadrants. Choose one that's going to be easy to work with. Another thing that's been an issue for some people is identifying quadrants. Like if I say that alpha is between pi over 2 and pi, I have people who still don't know where to put that. Okay? I have people who don't know where to put that. And so it's just important to remember that as we're looking at our quadrants, okay, we start at 0 here and rotate this way. There's pi over 2. There's pi. So if it says between pi over 2 and pi, it means literally it's in this area here somewhere. There's the area between pi over 2 and pi. Somewhere up there. And that's quadrant 2. So my x is negative, my y is positive, and my r is always positive. So you really have to watch your quadrants when you're working with your non-identity angles. So you get a lot of people who are putting them in the wrong quadrant and coming up with the wrong values. Let's take a look at a couple sample problems. Let's do this identity one first. Exact value for tangent of 5 pi over 12. It's in radians. Big deal. Okay? Well, how can we get to 5 pi over 12? Well, let's think about that. 5 pi over 12. Well, that's 1 pi over 12 plus 4 pi over 12. Okay, that doesn't help me because that's not an identity, so that combination is going to work. So I can do 2 pi over 12 and 3 pi over 12. Well, that works. This is pi over 6 plus pi over 4. But before I proceed, I want to make sure those are going to give me nice numbers. What's the tangent of pi over 6? Tangent of pi over 6. Root 3 over 3. Ooh, that's not something I'm going to be interested in. So, probably not. And you're saying, but wait a minute, there's nothing else that adds up to 5 pi over 12. Those are all my choices. Who said it had to be addition? Who said anything about it having to be addition? I could also do 5 pi over 12 as 6 pi over 12 minus 1 pi over 12. That doesn't help and doesn't reduce. How about 7 pi over 12 minus 2 pi over 12? Nope, not identity. 8 pi over 12 minus 3 pi over 12. Ah, those are both going to be identities because they both reduce. What's the tangent of 8 pi over 12? Well, it's tangent of 2 pi over 3, right? Negative root 3, and this is going to be 1. So that's the combination I'm probably going to want to use. And the reason I didn't choose this one again is because this gave me a tangent value. Tangent of pi over 6 is root 3 over 3. That's a frown face situation. I don't like that. Here, tangent of 2 pi over 3 is negative root 3. That's a happy face. The pi over 4 tangents are always 1s and negative 1s. So first is deciding which values to use. Once I've got my values set up, now I just plug in the formula. Since it's going to be the tangent of 2 pi over 3 minus pi over 4, and do not switch it to degrees. You're in radians, work in radians.
Interruption. At this time, please allow Mrs. Vera's 8th-hour students
to
report to their classroom. Thank you.
So that's tangent of, so according to formula, it's tangent 2 pi over 3 minus tangent pi over 4 over 1 plus tangent 2 pi over 3 times tangent pi over 4. We plug in our values. Tangent 2 pi over 3 is negative root 3 minus 1 over 1 plus negative root 3 times 1. Or negative root 3 minus 1 over 1 minus root 3. Now, I can't just reduce that and cancel it. I have to rationalize it. We rationalize it by multiplying by the conjugate of the denominator, which would be 1 plus root 3, numerator and denominator. And now we FOIL. Negative root 3 times 1 is negative root 3. Negative root 3 times positive root 3 is negative 3. Negative 1 times 1 is minus 1. Negative 1 times root 3 is minus root 3. Over denominator, 1 times 1 is 1, plus root 3, minus root 3, minus 3. That's negative 4 minus 2 root 3 over, cancels negative 2. So I factor negative 2 out of the top. That's negative 2 plus root 3 over negative 2. Negative 2's cancel. 2 plus the square root of 3. There's my solution. And these solutions always come up as 2 plus root 3, 2 minus root 3, negative 2 plus root 3, negative 2 minus root 3. Yes?
What Okay. You lost me when you started with the blue. I don't know what happened.
Whenever we have a binomial denominator like that with a radical, the only way to eliminate that radical is to multiply by the conjugate of the denominator.
Okay.
That's old algebra 2 stuff, yes.
Okay, now I get it. You simplify that to get, now I get it. Never mind.
Okay, yes.
How'd you get from the -4 to the answer?
I factored a -2 out of the numerator to cancel a -2 in the denominator. So I divided this by -2 and that by -2. Give me +2, +√3. The -2's, then, because they're factors, can cancel. Honestly, what I see a lot of when we get here is people starting to cancel parts. You may not cancel parts. Your answer should always look something like this: 2 plus √3, -2 plus √3, 2 minus √3, -2 minus √3. It's just like with the other ones, where it's got square root of 6 plus square root of 2 over 4. We've got the same type of answer, just some variation on that answer. We get the same thing here. We're always going to get some kind of variation on that answer. Let's look at one that's non-identity. Sine of x is 8/17 between 90 and 180. Cosine of y is 3/5 between 0 and 90. Find the tangent of y minus x. Now notice we went y minus x, and that's fine. Formula tells me that's going to be tangent of y minus the tangent of x over 1 plus tan y tan x. I'm going to have to figure out what the tangent of y and tangent of x is. I don't know either one, so I'm going to have to draw pictures. This is x. X is in quadrant 2 between 90 and 180. The sine is 8/17. So that's going to be a -15, a Pythagorean triple. So the tangent of x is -8/15. Y is in first quadrant. Cosine is 3/5. So that opposite side is 4, Pythagorean triple. Tangent of y, opposite over adjacent, 4/3. So we draw our little pictures and we get our values. We've been doing that for all of our problems so far, right? Yeah.
You can set up radians like that.
Sure. The only thing difference radius will say between negative or pi over 2 and pi. It doesn't matter. We'll put the limits differently. It's not going to change anything.
Can you do it if you don't have the
No, you can't do it without if you don't know which quadrant you're in.
Okay.
You have to know the quadrant. We just substitute in our values. Tangent of y is 4/3 minus -8/15 over 1 plus 4/3 times -8/15. Now we got some fraction work to do here, but that's okay. It becomes plus a positive. 4/3, we have to get a common denominator here. So that's 20/15, right? So that's 28/15 in the numerator. My denominator, it's 1 times 1 plus that, so that's 1 plus -32/45. 1 is 45/45. 45 minus 32 is 13/45. So now we have a fraction over a fraction, so we change that to multiplication. Flipping the second fraction. Reduce, making life easier. 3 times 28 is 60 plus 24, 84. 13. And there's my value. Doesn't reduce. The biggest thing about the tangent formula is it's a lot more arithmetic and algebra type stuff. You have to know how to simplify fractions. You have to know how to work with radicals. That's what's harder about it. The formula itself is pretty simple. And the techniques we're doing are exactly the same as what we had before. We aren't changing the techniques we use for sine and cosine. We're still using the same types of techniques. We're still setting up the same triangles. We're still working with those identity angles. You are going to have to know your identity angle values. There's no way around that. One last quick note. If you have to find something negative, let's just very quickly review. Let's say I've had to find the cosine of negative 75 degrees. When we're doing these angles, we have to use positive angles to get to negative 75. I can't do negative 30 plus negative 45. Those are not in my 0 to 360 range. I want to use positive angles to get there. So I'm going to have to say cosine of, say, 60 minus 135 to get there. So that's going to be cosine 60, cosine 135. What's my sine going to be for cosine difference formula? Plus sine 60, sine 135. So that's cosine of 60 is 1/2. Cosine of 135 is negative root 2 over 2. Sine 60 is root 3 over 2. Sine 135 is root 2 over 2. So that's negative root 2 plus root 6 over 4. Now, if you haven't done any of the homework yet, the stuff from last Monday and Tuesday, if you haven't touched that yet, and you looked at that problem right there and said, I have no idea what that formula is, where it came from, or what's going on, yeah, you're going to be in a real world of pain tomorrow on the quiz. If you don't know, if you're saying, how'd you get those values for sine and cosine, it's going to get ugly really fast. You really have to have, we've been talking for weeks about how you have to have your identity values memorized, one way or another. You're going to have, if you look at this math and say, how did you get from here to here? It's going to get ugly, because this is the kind of stuff that you learn through repetition by working problems. And if you try to cram it all into one night, it's not going to end well. It really is not. So hopefully you have been working on it. I will be checking homework right at the beginning of class tomorrow. Believe me, this is not one of those quizzes you want to say, oh, I'll just wait and do it later. The makeup quiz on this is super hard. So there's a huge difficulty penalty for having the makeup quiz on this. Just keep that in mind. So that gets us through essentially, I mean, most of our lesson and the review, because this is the review. Just very quickly, our formulas that we have again. Cosine of alpha plus beta is cos alpha cos beta minus sine alpha sine beta. Cosine of alpha minus beta is cos alpha cos beta plus sine alpha sine beta. Sine of alpha plus beta is, whoops, didn't mean that. Sine alpha cos beta plus cos alpha sine beta. Getting ahead of myself. Sine of alpha minus beta is sine alpha cos beta minus cos alpha sine beta. Notice it's like a cosine sandwich. The sines are on the outside, the cosines are on the inside. On both these formulas, the sines are the same here as they are here. With cosine, the sines are opposite. So little hints to help you remember the formulas. And again, our tan formulas from today. That pretty much reviews everything as well. Every technique that we use from this point on is exactly the same. All we have are different formulas. So even if you're going to make a mistake somewhere on simplifying, if you get a difficult problem like, that one isn't so bad. If you get something like this and you get this far but you have difficulty simplifying that, at least be sure you're showing every step of your setup. What values are you using? How do you get there? What are the values you get for cosine? If you can show me that you got the correct values for tangent of 2 pi over 3 and pi over 4, even if you can't quite simplify it perfectly, you're still going to get most of the points. If you got the wrong formula, you're pretty much done. But for cosine, the signs are different. For sine, the signs are the same. For tangent, the signs are the same in the numerator, different in the denominator. There's all sorts of little tricks you can use here. But repetition, doing a lot of these problems, is how you're going to learn it. You have to work it and work it and work it. So if you've waited, you're going to be doing a lot of work in it tonight. I mean, a lot. Maybe it'll be enough, maybe it won't. Hard to say. Okay? That's it. That's what we missed yesterday, plus a good portion of the review. So, I know it's squeezing it in, but that's the way it goes.
Okay, so I have a
Hold
problem.
on.